I want you to imagine just for a second two distinct, seemingly magical scenarios taking place in the digital background right now.
Okay.
So in the first one, you walk up to a digital checkout and a camera instantly guesses if you're old enough to buy a restricted product just
Mhm.
by looking at the way you move your hands to reach for it.
Right.
And then in the second scenario, an AI agent finishes this long, grueling day of reviewing legal documents, logs off, and literally goes to sleep to dream about how it can, do its job better tomorrow.
Which, I mean, that sounds completely like science fiction.
It really does.
But both of those scenarios
Yeah.
are entirely real, and they are actively shaping the digital infrastructure you use every single day.
Well, welcome to our deep dive. Today we are bypassing the surface level hype to look at how artificial intelligence is fundamentally shifting its role in our lives.
Yeah, moving away from just being a tool.
Exactly. We're looking at an Australian trial from August 2025 that focused on AI evaluating us, and then a developer update from Anthropic released yesterday, May 6, 2026, about AI evaluating itself.
Right, the Claude Managed Agents update.
Yeah, and the common thread here is really that AI is no longer just this, static chatbot you type a query into. It's becoming an invisible, continuous background process.
And that ambient nature is really what makes this transition so significant. The technology is moving from the foreground to the background.
Totally.
And to understand how that works, we really have to look at the mechanisms of evaluation. So the Australian Age Assurance Technology Trial Report is, well, it's a perfect place to start because it deals with AI attempting to evaluate something deeply human, which is our age.
I found the terminology in this report really fascinating because they draw a very hard line between age verification and age estimation.
Yes, very different concepts.
And for anyone listening who, values their privacy, you really want to understand this difference. Age verification is the classic method. It checks official records, a driver's license, a passport.
Right, it knows your name.
Exactly. It knows your name, your address, your exact date of birth.
Whereas age estimation does none of that.
None of it.
The AI has absolutely no idea who you are, and its architecture is specifically designed to keep it that way.
Which is wild to think about.
It is. It evaluates biological or behavioral features to produce a probabilistic binary answer. It just looks at the data and outputs, is this person likely over 18, yes or no?
So it's essentially like a nightclub bouncer.
Oh, that's a good way to put it.
Right. You walk up to the velvet rope, the bouncer looks you up and down, decides you look, say, 25, and just unhooks the rope.
Yeah.
And the moment you walk inside, the bouncer magically erases your face from their memory completely.
That nightclub bouncer metaphor actually maps perfectly onto the 4 strict stages these systems use.
Oh, really?
Yeah, so the first stage is capture, where the system takes a biometric sample, like an image.
Okay.
The second is analyze, which is running that raw data through a trained machine learning model.
Making the guess.
Right. Third is provide outcome, which is just sending that binary yes or no signal back to the website or the checkout kiosk.
Just a simple yes or no.
Exactly. And the fourth, and arguably the most vital stage, is instantly delete.
It's just gone.
The biometric sample is destroyed the millisecond the outcome is generated.
And the way vendors privately and private-eyed are executing this takes the privacy aspect even further.
Yeah, with Edge AI.
Right, Edge AI. For those unfamiliar, that basically means this entire 4-step bouncer process happens locally on your own device.
So important to note.
Yeah, the calculations are happening on the microchip inside your phone or your tablet. There's no cloud server involved.
Meaning there's no massive centralized database of selfies just sitting out there waiting for a hacker to breach it.
Which is a huge relief. The privacy by design is super robust. But the engineering trade-off here comes in the form of accuracy.
Of course.
Because the AI is inherently guessing based on training data, it is going to make mistakes.
And in data science, we measure the accuracy of that guessing using a metric called mean absolute error, or MAE.
And I was looking at the verifiable data in the report from a vendor called Yoti, and the progress curve there is steep.
It really is.
Back in 2019, their system's mean absolute error was 3.22 years.
Meaning, on average, it was off by over 3 years.
Right, which is a lot. But by 2025, that error had dropped down to 2.4 years overall.
Yeah, a significant improvement.
And when you look at critical thresholds, like guessing if someone is around 18, the margin of error is approaching just 1 single year.
Because the neural networks are becoming incredibly adept at mapping microfeatures.
Wrinkles and stuff?
Yes, but even more subtle. They're analyzing the elasticity of the skin, the spatial relationships between facial landmarks, and really subtle textural changes that correlate with aging.
Okay, but let me push back on this a bit.
Sure.
Because if I'm running a platform that sells adult content or, an online casino, a 1-year margin of error is a massive legal liability.
Oh, absolutely.
If my system looks at a 17-year-old and guesses they are 18, I am breaching the law. Even an error rate of 2.4 years means a 16-year-old could easily slip through.
You are identifying the exact core vulnerability of probabilistic systems here.
Right, because it's just guessing.
Engineers know the AI is going to be wrong a certain percentage of the time. The solution isn't to wait for perfect AI, which honestly might never exist.
So what do they do?
The solution is to build what is known as a buffer threshold.
A buffer threshold.
Yeah, the statistical data reveals a very helpful pattern, which is that the margin of error tends to drop to near zero when you evaluate subjects who are 2 to 3 years away from the target age.
Let me see if I follow this. If the target is 18, the AI might struggle to tell a 17-year-old from a 19-year-old.
Exactly.
But a 12-year-old is practically never going to trick the system into thinking they are 18.
That is the functional reality, yes.
Okay.
So if a platform absolutely requires users to be over 18, they just configure the AI's approval threshold to 21 or older.
So they build a digital buffer zone.
Precisely.
The AI is only allowed to automatically open the gate if it is overwhelmingly confident you are at least 3 years older than the legal requirement.
Yes.
It's kind of like being 35 and getting carded at the grocery store because the cashier's internal buffer zone is set to 40.
That's the perfect human equivalent, yeah.
Yeah.
Anyone the AI estimates to be 21 or older gets a seamless, frictionless pass.
And anyone who looks clearly under 15 gets an instant denial.
Right, so the critical engineering challenge is how you handle the people in the middle, that 18 to 21 demographic who fall into that statistical gray zone.
And the report mentions vendors like Lucidity and VerifyMe using a process called successive validation for that exact group.
Yes, which is a great fallback.
If the AI flags you as a 19-year-old, it realizes you are in the buffer zone, so it gracefully falls back to a secondary method.
Right, it doesn't just block you.
Exactly. It might pause and prompt you to upload a physical ID or complete a mobile carrier verification.
So you let the vast majority of clear adults through instantly and only add friction where there is statistical doubt.
It's really clever.
The elegance of that system is undeniable. We must, however, look at who is disproportionately getting caught in that buffer zone.
Yeah, the bias issue.
The Australian trial highlighted a significant demographic challenge. The technology struggles with non-Western training data sets, and specifically darker skin tones.
I pulled the Fitzpatrick scale data from the trial, and the disparity is glaring.
It really is.
For context, the Fitzpatrick scale categorizes human skin tones from type 1, very fair, to type 6, very dark.
Right.
And the trial showed that users with skin types 1 and 2 had a mean absolute error of 2.71 years. But for users with skin types 5 and 6, the error rate jumped to 3.01 years.
Which is a big jump. And the physics of optics play a large role here.
How so?
Well, traditional camera sensors rely heavily on light reflection to capture contrast and depth. Lighter skin reflects more light, providing the algorithm with a highly detailed topographical map of facial landmarks.
Oh, I see. And darker skin.
Darker skin absorbs more light, which, under standard or poor lighting conditions, reduces the contrast and the sheer volume of data available for the neural network to analyze.
Which practically means darker skinned users are mathematically more likely to get caught in that buffer zone and be forced to pull out a physical ID.
Exactly. And to benchmark this fairness, the report adopted the 4-fix rule.
Right, which basically states that no demographic group should experience more than a 20% disparity in outcome error relative to others.
Meeting that benchmark is so critical because of the downstream effects.
Yeah.
We have communities, such as First Nations populations, who may be statistically less likely to hold official government-issued identity credentials.
So if the AI continuously defaults them to the buffer zone, forcing them back to physical IDs.
The technology ends up excluding the very populations it should be helping to include.
So if stand-up cameras and lighting inherently struggle to capture equitable data across certain skin tones, how do we solve this without just, abandoning the technology entirely?
Well, we stopped looking at faces entirely.
Wait, really?
Yeah, the trial monitored some emerging modalities that completely bypass facial bias. A vendor called Needemand is actually testing gesture-based age classification.
Oh, this was the first scenario we talked about in the intro.
Exactly.
The AI guessing your age by how you move your hands? How is that even physically possible?
It all comes down to the biomechanics of the central nervous system.
Okay, color me intrigued.
The AI isn't looking at the size of your hand or the color of your skin at all.
Right.
It is analyzing the geometry and the dynamics of your movements through the camera.
So how you physically reach for something.
Exactly. A 12-year-old picking up a smartphone has subtle differences in motor control, grip pressure, and reflex speed compared to a 30-year-old.
Because the 30-year-old's brain is fully developed.
Right, their neural pathways are fully myelinated and mature.
So an adult's swipe or tap on a screen is going to be smoother and more decisive, whereas an adolescent might have like micro hesitations or different velocity arcs.
You've got it. The algorithm tracks those physical movement patterns, mapping the velocity and the arc of the gesture to give that exact same binary outcome.
Likely over or under the age threshold?
Yes, and it guarantees complete anonymity.
Because it's just motion.
Because it relies purely on physics and motor development
Right.
rather than facial topography, it neutralizes algorithmic bias based on skin tone completely.
You know what fascinates me about these gesture mechanics and the whole buffer zone concept is the underlying philosophy.
Which is,
Data scientists are openly admitting that AI makes mistakes.
yes, they have to.
It's probabilistic, so instead of pretending it's perfect, they build safety nets and secondary graders around it to catch the errors.
Right.
And Anthropic just took that exact same psychology and applied it to generative AI, which brings us to the developer blog published yesterday.
We are witnessing a fundamental pivot here. The industry is moving from using AI to evaluate human traits to building systems where AI rigorously evaluates its own cognitive work.
Evaluating itself.
Yes. The Claude Manage Agents update is just a profound leap forward in how we deploy these models.
So the update introduces a public beta feature called Outcomes.
Yes.
And up until now, using AI meant writing a prompt, hitting send, and basically crossing your fingers hoping it didn't hallucinate.
A lot of hoping involved.
Yeah, but Outcomes changes the entire loop by letting developers provide a rubric instead of just a prompt.
And that rubric is a strict, measurable definition of what success looks like for that specific task.
Okay.
To understand why this is so necessary, we really have to look at the architecture of large language models.
Yeah, how they actually write.
They are autoregressive, meaning they predict the next word based on the words they literally just wrote.
Right.
So if an AI makes a slight logical error early in a response, it will stubbornly continue down that flawed path because it is statistically bound to its own generated context.
I think of it kind of like trying to edit my own writing.
Oh, that's a perfect analogy.
If I write a really complex essay and then immediately try to proofread it, I am almost guaranteed to miss my own typos or logical leaps.
Because you're too close to it.
Exactly. My brain knows what I meant to say, so it just autocorrects the mistakes on the page as I read. I'm biased by my own thought process.
Right.
I need a fresh pair of eyes to grade my work objectively.
And that is the exact mechanism Outcomes replicates.
Oh, cool.
If you ask an AI to critique itself in the exact same chat window, it suffers from that same cognitive bias you just described.
It's just reading its own bad essay.
Exactly. So Outcomes spins up a completely separate instance of Claude, running in its own pristine, empty context window.
Literally a completely fresh pair of eyes.
Yes. This secondary grader agent looks at the original output and evaluates it strictly against your rubric.
Okay.
It has no memory of the reasoning path the first agent took to get there, making it remarkably objective.
Because it doesn't know why the first agent said what it said.
Right. And if the output fails the rubric, the grader pinpoints the exact failure and kicks it back to the original agent for a rewrite, creating this automated loop of self-correction.
And the real-world data Anthropic shared on this is wild.
The benchmarks are impressive.
In their internal benchmarks, running this objective grader resulted in a 10 percentage point jump in overall task success.
A flat 10% increase.
Yeah, and for specific complex tasks, they saw an 8.4% boost for generating formatted Word documents and a 10.1% boost for PowerPoint presentations.
And the applications extend far beyond just technical formatting.
Right, there was the example with Spiral by Every.
Yes, Spiral by Every uses the Outcomes feature to enforce subjective quality, specifically their editorial voice.
Which is notoriously hard for AI.
Very hard. The grader agent evaluates every generated draft against a highly detailed rubric of editorial principles.
Okay.
If the draft uses cliches or the tone is just slightly off, the human user never even sees it.
Well, it doesn't even show you the bad draft.
No, the system just quietly revises the text in the background until it clears the bar.
Which is incredible for, one task.
Yeah.
But the update didn't stop there. They also launched multi-agent orchestration. So we aren't just talking about a writer and a grader anymore.
Yep. We are scaling up.
Developers can now spin up a lead coordinator agent that can delegate tasks to up to 20 specialized subagents simultaneously.
We are really moving into complex topology now. The coordinator acts like a project manager, breaking down a massive, complex problem into digestible pieces.
And Netflix provided a brilliant use case for this, didn't they?
Yes, their platform team built an analysis agent to process system logs across hundreds of software builds.
Finding anomalies in server logs is basically like finding a needle in a haystack of static.
It's impossible for a human to do quickly.
Yeah, and a single AI agent would get completely lost in a context window of that size.
The context window just becomes overwhelmed by noise.
Right.
But with multi-agent orchestration, the coordinator spins up parallel subagents. Each subagent takes a specific batch of logs and analyzes it simultaneously.
So they are all working at the exact same time.
Yes. The subagents report back their findings, allowing the coordinator to sort of surf above the noise and identify recurring patterns across the entire distributed system.
There is a really important technical limitation Anthropic put on this swarm, though.
The depth restriction.
Yeah, they restricted the depth of these subagents to 1.
Right.
Meaning the lead coordinator can delegate a task to a subagent, but that subagent cannot then turn around and hire its own subagents.
And that limitation is so crucial for traceability and safety.
Why is that?
Well, without a depth restriction, you risk runaway fractal delegation.
Fractal delegation? That sounds expensive.
It is. An AI encounters a problem, spawns 3 agents to solve it, those 3 spawn 9 more, and suddenly you have an infinite loop of agents communicating with each other, achieving absolutely nothing and draining a massive compute budget in minutes.
Yikes. So a depth of 1 just keeps the swarm flat, predictable, and manageable.
Exactly.
Even flattened out, though, having 20 parallel agents working a problem is a massive leap.
It really is.
But all of this, the unbiased grading, the orchestrated swarms, is really just setting the stage for the most futuristic update Anthropic announced.
The big one.
Yeah, it's currently in research preview, and it is called Claude Dreaming.
This fundamentally alters the trajectory of machine learning deployments.
How so?
Well, prior to this update, an AI suffered from severe digital amnesia.
Right. If an agent spends 4 hours doing a highly complex legal review, it might figure out a brilliant workaround for a corrupt PDF file.
Or it might learn that the human user prefers summaries and bullet points rather than long paragraphs.
But the second you close that browser window, the agent forgets everything.
It's gone.
Every new session starts completely from zero.
And dreaming is a scheduled background process designed to cure that amnesia. It is an unsupervised learning phase where the system reviews past agent sessions, extracts those hard-won problem-solving patterns, and permanently updates the agent's behavioral guardrails.
See, I initially struggled with this concept a bit because Claude already has a memory feature.
Yes, people confuse the two.
So why do we need a separate dreaming phase?
The distinction lies in the timing and the cognitive load.
Okay, break that down for me.
Memory happens during the active session. It is the agent quickly jotting down a sticky note.
Right, remember they like bullet points.
Exactly. Dreaming, on the other hand, happens after the session when the computational resources aren't tied up in serving the user.
Ah, I see.
Consider how human memory consolidation works during sleep. Throughout the day, your brain takes in a massive amount of stimuli.
Just nonstop input.
Right. And when you sleep, your brain replays those experiences, prunes away the irrelevant noise, and crystallizes the important patterns, turning short-term events into long-term behavioral changes.
So Claude Dreaming is mimicking human sleep consolidation, but it's doing it across hundreds of different user sessions all at once.
Exactly. A customer support AI in chat session 47 has no idea that it made the exact same policy hallucination 12 times last month in other sessions.
Because they're wall off from each other.
Right. It cannot perceive the macro trends.
Oh.
The dreaming process analyzes the logs of all those disparate sessions, identifies the recurring failure point, and writes a new global instruction rule to prevent that specific mistake in the future.
It's writing its own operational manual in the background.
Yes.
It notices, hey, I keep failing at X, so my new permanent rule is Y.
And the business results they reported from this are staggering.
Yeah, a company called Harvey, which builds AI for law firms, tested this streaming capability
Like a perfect use case.
by allowing their agents to consolidate memories, carrying institutional knowledge and workflow shortcuts across sessions. their task completion rates jumped by a factor of 6.
6 times more effective.
Yeah.
And not because Anthropic released a larger, smarter base model, but purely because the customized deployment learned from its own historical successes and failures.
And doing all of this background consolidation only costs $0.08 per runtime hour.
That's practically nothing.
The economics of this are paradigm shifting. It turns AI from a transactional tool into a compounding asset.
Yes, the longer you leave it running, the smarter your specific deployment gets.
The value of the AI is no longer just in its initial training data.
Exactly. It is in its accumulated experience.
Which brings us right back to our starting point. For you, listening right now, the through line connecting these two very different technologies is clear. Artificial intelligence is becoming ambient.
Truly ambient.
Whether it's an age estimation algorithm silently analyzing the biomechanical geometry of your hand gestures at a checkout kiosk,
Or a swarm of 20 Claude agents reviewing legal contracts and then sleeping to consolidate their memories for tomorrow.
right, the nature of our interaction has changed. We are moving away from tools we actively query toward a silent ecosystem that runs, learns, and corrects itself in the background of our lives.
And that transition leaves us with a really profound concept to consider.
What's that?
Today, we configure age estimation AI with strict buffer zones, and we configure generative AI with rigid rubrics to keep it in check.
Because we know they mess up.
Exactly. We do this because we know the models make mistakes, and we are still the ones grading them. But if Claude is now dreaming to autonomously rewrite its own long-term behavioral rules, and biometric AI is actively learning to read our subtlest physiological signals, at what point does the AI's internal compounding model of the world become more accurate than the human rubrics we built to constrain it?
Wow, that is a wild thought to leave on. Do we eventually reach a point where we trust the machine's dreams more than our own rules?
It's definitely coming.
Well, thank you for joining us on this deep dive. Keep asking questions, keep exploring, and we will catch you next time.